In this lesson, we're going to discuss the container lifecycle and all of the possible states. We know that a container only exists as long as its primary process is running. So what happens when a container exits? Let's run our Hello O'Reilly container and see what happens after it exits. This container simply echoes some text, so it immediately exits. If we run docker ps, we should no longer see our running image. As expected, it's gone, but we can still see it using ps-a, which shows all containers, running or not. There's our container, and the status is marked as exited. If we wanted to run the container again, we could simply issue the same run command we did earlier, or we could use docker restart. Using restart would restart the container rather than creating a new identical one. We don't see our Hello O'Reilly message this time. Instead, we just see the container name. This is because docker restart will run the container in detached mode. A command completing is one way for a Docker container to exit. We can also stop a long-running container explicitly using the docker stop command. Using docker stop will initially send a sigterm signal, followed by a sigkill signal. Using docker stop allows us to try to allow the container process to exit gracefully. The sigkill will happen if the container fails to do so, just to ensure that the container eventually exits. I've built a new image to test out stopping and killing containers called O'Reilly Shut Me Down. This image will start a Ruby web server that will continue to run until we stop it. The application in the container has a shutdown hook that performs a fake shutdown sequence. Let's run it in the foreground and see what happens when we stop it. Since we're running the container in the foreground, we can use Ctrl-C to gracefully stop our container. This will trigger a 5-second shutdown process, followed by a graceful shutdown message. Okay, the web server started up, so let's stop the container using Ctrl-C. After 5 seconds, we see a message that the application shut down gracefully. Running this container detached will allow us to experiment with stopping containers. Let's run it again in detached mode using the -d flag. In our other terminal window, we can use the docker logs command to watch the output. Back in the first window, let's execute docker stop. Docker stop can be augmented with the time flag, which tells Docker how long to wait before issuing a kill signal after issuing sigterm. We know that the process in our container takes 5 seconds to shut down, so let's be on the safe side and allow it 10 seconds before the kill is issued. As we can see on the window on the right, the application completed its graceful shutdown sequence. So let's try it with a shorter time. We'll do 1 second this time, which is clearly shorter than the graceful shutdown period of our application. Notice on the right that the application started to shut down, but the process ended before the shutdown sequence completed. This is because Docker issued sigkill to the process. In most production situations, we don't want this to happen. Imagine running a web server at scale. You would want your server to gracefully shut down and let existing connections drain before killing the process. Other applications that need to perform resource cleanup upon shutdown would also need to be stopped in this manner. There are some cases where we really do need to kill a container flat out, and we can use docker kill for this. And so we killed the process without sending the term signal first. Being stopped isn't the final state of a container lifecycle, though. Once a container is no longer running, we can use docker rm to remove the container. Keep in mind that once you remove a container, there's no way to undo it. And notice when we run docker ps-a that the container named shut me down is no longer in the list. Understanding the container lifecycle and handling of signals becomes extremely important once you begin launching real applications at scale.